Tonight, our presentation features wildlife biologist Keith Oster. Keith studied mineral nutrients and foraged in Arctic caribou during grad school, and now he works in our Bethel office where he is studying a rapidly growing moose population. Welcome, Keith.
Hey, thanks, Deb. I am the Assistant Area Wildlife Biologist for Game Management Unit 18 located in Bethel. Before we get going, I just wanted to give a brief overview of Unit 18. It's a part of the state that not a lot of people tend to make it to. Unit 18 is roughly 45,000 square miles. It contains the lower portions of the Yukon and Kuskokwim rivers. And it also has about 25,000 people in it, making it the most densely populated rural area in the state. Other than moose, which we're going to talk about a lot today, we have about 1,300 muskox in the unit, most of those on Nunivak and Nelson Island, but also at a low density throughout the unit. We have some caribou in the southern portion, and moose are relatively recent colonizers of the unit, relative in the 20th century. And right now we probably have about 30,000 moose in the unit, and that's probably comparable to other units to some other units in the state. But Unit 18 is largely treeless tundra, so all of those moose are packed into, especially in the winter, mostly riparian corridors along the Yukon and Kuskokwim rivers. So like I said, they've only recently started becoming established. They first came into the unit, according to talking to tribal or records from tribal elders and early biologists in the unit. They came in about 1930s, 1940s. There was a long period of slow growth or even stagnation at a low density until probably the 1980s, 1990s. On the Yukon, they really started to take off further south. They took off a little bit later than that, maybe early 2000s. Sorry, got a little ahead of myself. So we'll just go back to the slide here. In the past few decades, we've seen rapid growth in these expanding moose populations to the extent that evaluating where these moose are relative to their carrying capacity is becoming quite important. This population, specifically on the Yukon that we're going to be talking about, provides a unique opportunity to evaluate moose nutrition in a rapidly growing population. And by studying those moose, we hope to develop tools to predict population decline in some of the highest density moose populations in the state. So here we have a map of Unit 18 and all of our moose hunts. Specifically, we're going to be focusing on, sorry, I'm a little lost here. Where'd my, there we go. Oh, I haven't been going through my slides, shoot. Okay, here we are, map of the Yukon, or map of Unit 18. So we're specifically going to be talking about this area on Unit 18 remainder, covers most of the western coast of Unit 18, and what we're going to be focusing on is here along the Yukon River. The last time we counted moose along the Yukon was 2021, and we estimated that just along the Yukon River there are 24,000 moose. Unit 18 remainder currently has really the most liberal bag limit for moose that's ever been seen in the state of Alaska. Currently, Alaska residents can harvest up to 3 moose over a 9-month-long season. Here are our moose survey areas on the Yukon. We have furthest downriver, we have the lowest Yukon survey area. In the middle, we have the Andrevsky survey area that covers the Yukon River and also goes up this tributary called the Andrevsky River. And then furthest upriver, we have the Pymute survey area. Now, the Pymute survey area has probably the longest occupation history of moose in the unit. There are stories from 80s and 90s of people from all the way down here, Luckenock, Amonic, Nunamiqua, Kotlik, loading up drums of gas and coming all the way up here so they could harvest a moose. And then the lowest Yukon survey area is kind of the shortest history of occupation. In the late 80s and early 90s, there was a moose hunting moratorium, specifically in that area downriver of Mountain Village, a 5-year moratorium where we'll see in that time period, we would fly for, not me, but biologists at the time would fly for, a couple days and spot 40, 60, 80 moose, something like that. And now downriver of Mountain Village in this lowest Yukon survey area, we estimate there's about 12,000 moose. So this presentation is broken down into 2 main parts. First, we're going to go over our survey and inventory activities and just kind of get a baseline idea of what this moose population looks like. And our survey and inventory activities are kind of what every management biologist across the state uses to manage their moose populations. First, there's abundance, just how many moose are out on the landscape. We also look at reproduction through twinning surveys. And twinning surveys, we fly around and we are only looking for cows that have calves with them. And then that twinning rate is the proportion of those cows with calves that have twins. So, we'll see later it's going to range from, for us, kind of in the teens all the way up to 60% in some of those early years. We also fly population composition surveys, and for that we're just trying to figure out how many bulls, cows, and calves are on the landscape, and that allows us to apportion up that abundance survey that we do to really get an idea. Instead of just how many moose total are on the landscape, we can do some math and figure out roughly how many bulls, how many calves, and how many cows and how many calves. And then the last one that we do is we look at browse removal rates during browse surveys. And when we do a browse survey, we're going out to these survey areas and kind of systematically measuring sticks, for lack of a better word. And what we're trying to estimate is the amount of food that's on the landscape and how much of that food that's been eaten over that winter. And for those of you that don't know, the food that's available to moose over the winter is everything that grew during the previous summer. And it all amounts to sticks that are really no bigger than your pinky. So first we have a graph of abundance and density. On the left-hand side, we have our abundance graph. In the blue, we have the lowest Yukon survey area, that one that's furthest downriver. And then the orange is the Pymute survey area, the one on the east side of the unit. In the Pymute area, starting in the early 90s, you can see there's roughly 1,000 moose. And over 10 or 15 years, that slowly increased up to about 5,500 in 2013, and has since then kind of showed some signs of stabilizing off. In the lowest Yukon survey area, like I mentioned, early 90s, we had almost no moose. I think these dots represent 60 and 80 moose respectively. And then starting in the early 2000s, it turns a corner and just really is a rocket ship up in terms of population trajectory. Here from 2005 until 2017, this population doubled roughly every 3 to 5 years, which is really phenomenal growth. And as of 2021, like I mentioned before, we're sitting right at about 12,000 moose. And everything tells us that it is still on the rocket ship up in terms of population trajectory. Over here, we have basically the same graph, but it's density. So as a function of the area or the actual area of the survey area. And the only reason I show this is, when I was doing my undergrad at UAF, you hear about 1 moose per square mile is a healthy moose population. And that's really an estimate for interior Alaska, where you have mixed forests, riparian areas, and all of that kind of mixed and jumbled together. Down here in Unit 18, we basically only have riparian areas. In the eastern side of the unit, there's some mixed forest and spruce and whatnot, but especially downriver of Mountain Village on the lowest Yukon survey area, it is all just willows, cottonwoods, and some alders. So we could probably support a little more than one, or some number more than 1 moose per square mile. But as we're going to see a little later, nearly 7 moose per square mile is probably too many. Next one we're going to look at is twinning rates. And this is for all 3 survey areas. Orange is the lowest Yukon, gray is the Andrewski, and yellow is Pymute. For this, it's not all that important. But you can see those twinning rates were up 50-60% early on in around 2010. And the biggest thing is that there's a declining trend here. So we use twinning surveys as an index of really habitat quality. And that just shows that over time there is a general downward trend, and that really indicates to us there's some sort of habitat stress beginning to develop. And in this big table, we have our moose composition results for lowest Yukon, Andrewski, and Pymute. And the 2 take-homes here, first with the cow-to-calf ratios, they are kind of unanimously, still even right now, quite high. Early on, 2010, we can see about 70 calves per 100 cows. And, it kind of goes up and down, but 61, 37, 39, it still tells us that this population is being quite productive, having that many cows survive the summer into the fall time when we do this survey. Next, the bull to cow ratio. We can see that generally those bull to cow ratios are increasing. So on the Yukon River, we harvest between 600 and 800 moose a year. And with that level of harvest, what this tells us is that we're increasingly unable to detect that there's even human harvest occurring. Right here, these bull to cow ratios of 60, 61, 57, this is kind of comparable to what we see in unhunted populations in Denali Park. So we are unable to even tell very well that we are harvesting moose on the Yukon. And finally, our browse removal rates. Lowest Yukon, you can see that they've increased from 23, 24% up to about 31. And Pymute, we haven't been doing browse surveys very long in the unit. So 2018 to 2021, they actually declined, indicating another indication that that population may be stabilizing to some extent. But when it comes to browse removal rates, once we hit 30% browse removal, so they're eating 30% of all the food that's available to them, we're having some serious concerns about habitat degradation and habitat quality at that point. Once that browse removal rate gets up to, say, 40%, at that point we're really expecting imminent population decline. And some of you might be thinking, 30-40% browse removal, that doesn't sound that bad. There's still 60 or 70% food available to them on the landscape. But as moose go out and they're eating, willows, cottonwoods, birch, first thing that happens is as they eat them, they break off those sticks where, they bite it and break it off, and the rest of that stick dies. and the bush or tree eventually becomes what we call broomed. And it's got a bunch of these sticks everywhere, poking up everywhere. And, the next year a new stick might grow, but all these hard, dead points sticking in their nose kind of make it harder for them to access that food. And also, as a plant is heavily browsed upon, we get plant secondary compounds. The plant realizes it's being eaten, so it makes phenols and tannins, which can either have a metabolic effect, so there's a metabolic cost, they have to process that toxin to get it out of their body, or they can actually bind nutrients too and make protein that's in those plants unavailable to digest. So even though there's 60 to 70% of that food available still, it's really either not that good of food or it's harder for them to get to. So just to summarize our survey and inventory data, moose numbers in the Lewis Yukon area are growing exponentially at this point. In the Piemute area, may be stabilizing. Twinning rates are declining, but still, I forgot to mention this, the lower twinning rates we're seeing now in other parts of the state would be considered quite high and quite good. Our bull to cow ratios have been increasing over time, indicating that we really can't tell we're actually harvesting moose up there, and browse removal rates are getting quite high. So when we started this project, we had some questions we want to answer. So first, how much do fall calves and short yearlings weigh among survey areas? So fall calves is pretty self-explanatory. It's calves in their first fall. And then short yearlings are moose in the spring that are just about to turn 1 year old. So 9, 10, 11 months, depending on when we do those captures. Next, we wanted to know, are there movements between study areas and outside of the study area? And do those movements relate to nutritional condition of moose between those two study areas? Third, what are the causes and rates of mortality across age groups? And then finally, what are the current parturition rates? And at what age are moose first reproducing? So finally, how do we collect this data? Of course, we go out and we capture young moose, calves and short yearlings. Once we capture them, we're able to get a weight off of them, and we'll put a collar on their neck, and that gives us movement data. It also gives us mortality data when those collars sit for, I can't remember exactly what it is, 4, 6, 8 hours. They actually send out a signal that tells us, hey, I might be dead. And very rarely, sometimes that moose was just taking a long nap and it walks off, but more often than not, we get in a helicopter and we can do a field visit or a field necropsy to try and figure out what happened to that animal. And then finally, because they're wearing a collar in the springtime as they get older, we can go find them during the calving period and determine if they have calves or not, and really give us a parturition rate. So twinning rate, we're looking at out of all the cows with calves that we can find, what percentage have twins? For a parturition rate, we want to know of all the cows on the landscape, how many are actually having calves? And those collars allow us to get that data. So first, this is how we weigh our moose. You can see we've got that, roughly 300 to 500 pound calf in a weighing sling, and Lincoln there has a scale and then a come along hooked above that, and we just use the come along to lift them up just enough off the ground so we can record a weight, and we slowly let them back down on the ground. And here we've got a short video of what a capture event looks like. From the time that we get a dart in a moose and it lays down to the point that it gets up and walks away, we try and keep that in the 10 to 20 minute ratio. And in this video, it looks like they've already got it in the sling. So they're just going to lift it off the ground, get their weight. They'll get that out of the way. At one point, they'll put a collar on it, roll it over. We were taking hoof scrapings, looking at levels of cortisol in the hooves, data that we don't have back quite yet. We were doing the same thing with hair. So they'll take some hair off of it and then get out a tape measure, take some measurements, give it its reversal, and you'll watch it get up and walk away. And you'll notice that that moose wasn't completely asleep. We don't put them completely out. You know, a good capture, the moose is head up, maybe looking around, somewhat aware that you're there, but they are just unable to get up and, you know, relaxed. So what do those weights look like? So you'll see I've got lowest Yukon and Pymute weights on here, and I also added some data that I was able to track down from the Seward Peninsula. So on the Seward Peninsula right here, you see in the fall. Now, before I get into that, I need to make clear that these are not recaptures. So these are not moose that we captured in the fall and then recaptured in the spring. These are all separate capture events, new animals. But we can still think about it, kind of each one is a little bit of an idealized moose, looking at how much weight they're using over the summer, and really, more importantly, or how much weight they're losing over the winter. And more importantly, how much do they weigh in the springtime when they're coming out of winter? So Seward Peninsula, where they are not habitat limited, this is really a picture of a moose living its best life. You know, in the fall time, they're 263 pounds, losing some weight over the winter and coming out at 400 pounds. That is still a moose that's in great condition in the fall or in the spring. In Pymute, going into winter at around that 400 pound mark and coming out at 360. This is a little bit of a moose on the edge. They're getting by, but you know, there's quite a few moose on the land, or young moose, calves or short yearlings, that are struggling in the spring. And in lowest Yukon, this really kind of paints a dire picture for those younger moose. Going into winter at 382, coming out an average of 313. You know, for a lot of these moose, you know, we'll see this in our mortality data later. It's almost a flip of a coin that if they're going to survive to their first birthday. So next, we're going to look at some location data. And before we do that, I wanted to show you guys our collars that we use. So we're hanging these collars on moose that are anywhere from, you know, 300 to 500 pounds, and they're going to wear this collar for the rest of their life. So how do you have a collar that goes on a, you know, 400-pound animal that also fits a, you know, 1,000, 1,200-pound cow? So you see here, there's a little bit of a bungee cord. We'll talk about that after the video. And then over here, there's some grooves that allow this collar to slide and open up as the moose gets older and bigger. So yeah, that bungee cord there, you know, moose are wearing these for their entire life, and after about, you know, 1 to 2 years, that bungee cord will start to UV rot. You know, it's going to go through freeze thaw cycles, and after about a year or two, it'll actually disintegrate away, and that collar will just fully expand and, you know, hang on the moose's neck like a necklace. So here we have a quick video, roughly 2 minutes long, showing, you know, all of our movement data for our moose on the Yukon River. We're starting out in March of 2019. April is when we put out our first set of callers. So in April of every year, you're going to see, or almost every year, we missed a few years due to COVID and whatnot, but in April, you'll see a flush of new dots on the landscape. Similarly, in the fall time, in October, November, you'll see that occasionally. And what we're going to be looking at is a 2-week moving window of waypoints. So it's going to look almost like little caterpillars crawling across the landscape as new waypoints appear and the older waypoints disappear on the back end. And as we go along, I'll just call out probably April and October. It tends to be when they make their biggest movements, either away from the river or back to the river. And yeah, here we go. First callers in April. See them starting to spread out a little bit. We're getting to October. Everybody's back to pretty much where we caught them. April again. You're going to spread out to their summer distribution. October, everybody's pretty much back where we caught them. We are in April again. October, coming home. Now in 22, we're going to see kind of a wider movement than we've seen in the previous years. And for that, there were some fires over by St. Mary's and Russian Mission. And our best guess is that some of those moose decided they need to get as far away from that smoke as possible. And a lot of those were collars that we put on. We went out in April, we hung collars on cabs, and Mom decided they needed to get the heck out of there. Here we are in 23 in April. Seems like those moose just, oh, I guess we walk for 400 miles over the summer, because that's what Mom did the first year she had me. It was down here south of the Kuskokwim. We have one moose that's decided that it likes it better down on, well, I guess our side of the unit. She's spending her second winter up there now. And then the other thing I wanted to highlight, there were a few moose that came out over here and down here and looked like they were trying to stick it out for the winter. And a lot of these moose that came out into this area, this is all just basically open tundra, they tended to die. They didn't survive the winter, probably because there weren't enough food and may have even been more susceptible to predators. And then this is just kind of a take-home slide. Right here, we have a typical winter distribution. Everybody piled up on the river. And then in the summer, most of the moose are actually still pretty close to home, but there are just a few of them that take really long walkabouts. This is probably a 150, 200 mile long trip right here. So now kind of the sad part, we're going to talk about causes of mortality. So first, up here, we have kind of a typical wolf kill. When a wolf catches a moose, the first thing they tend to eat are kind of the soft parts of the animal, the ears, nose, tongue. And then in the corner on this side, we have a typical grizzly bear kill. And honestly, those just look like mayhem at the kill site. There's tundra ripped up, they're caching pieces or the whole animal under the ground. The trees scratched up, debarked, almost looks like a bomb went off when we come up on one of those grizzly bear kills. And then the biggest causes of mortality that we have seen are starvation. So in that case, this is what we see. It just kind of looks like they laid down and took a nap and never got up. And when we kind of come to an animal like this, we will do a field necropsy. We'll cut them open, we'll look at the lungs, the liver, we may take a sample of the liver, and we'll also cut out the femur and crack it open. And this is this animal's femur bone marrow. So I'm sure almost everybody's seen a soup bone in the store. Bone marrow really should be this pinkish, milky, waxy, pastel pink color. And this animal has literally just given everything that it's got. Moose store fat, and we think of three different spots on their body. We have subcutaneous fat under their skin, cavity fat, it's in amongst the intestines, around the kidneys, around the heart, and then fat that's in their bone marrow. And they tend to use them in that order. So first, if they're nutritionally stressed, they'll metabolize their subcutaneous fat, then their abdominal fat, and finally, as a last resort, they'll start to metabolize their bone marrow fat. So like I said, this is a moose that gave everything that it had, and almost came up just short of making it to its first birthday. And here, just a quick graph of our causes of mortality. Like I mentioned, the vast majority of these young moose that we're following are dying of starvation. 14%, we don't know what happened. We're a rural area with complicated logistics. Sometimes we're just not able to get out there fast enough. There may be, we get to the scene and there's some compounding evidence that we're not sure about. We'll label those as unknown. And then about 12% have been predation by either bear or wolves, 4% from bears and 8% by wolves. So here we have some of that mortality data. On the left, we have a Kaplan-Meier survival curve. So this just shows for every year of a moose's life, what percentage survived that age class. So this 0 to 1, I just want to point out, we're capturing these moose, at the very earliest before or after they've already survived the summer. So really, this first year is just overwinter survival. And we see that, about 35% of our young moose are not surviving to their first birthday. In the second year, we're losing about 5% of our moose. And then after that, they may be struggling nutritionally, probably mostly lower reproductive rates, but they're surviving. On the right side, we have, just number of mortalities by month of the year. And you can see that most of those mortalities are in April and May, right before green up. They're almost making it, but just coming up short and passing away in the leanest time of the year. So next, we can talk about something a little happier, reproduction. So identifying cows in the spring that have calves and determining if they are singles or twins helps us to understand more about nutrition and population trajectory. And then, like I mentioned, because we have those radial collars, we can follow individuals through time. And at least for the cohorts that we have collars on right now, which is age 1 through 6, we can determine a parturition rate for those age classes. So again, we've got a couple of graphs here. On the left-hand side, we have parturition rate by cohort or age. Well, I have some other data here from the Seward Peninsula I didn't put up on the screen. So we have yet to observe a 2-year-old with a calf, where on the Seward Peninsula, where they're not experiencing that nutritional stress, their parturition rate was 28.5%. So pretty comparable to what our 3-year-olds are doing. And then their 3-year-old parturition rate was 78.5. So our 6-year-olds aren't even, meeting the parturition rate that we see in areas that aren't nutritionally stressed. That just tells us moose are, delaying their first reproduction at least a year. And, even as they get older, their reproductive rates are lower than they would be had their habitat been better. Other thing we look at is age at first reproduction. Again, we haven't observed a moose at 2 years old having a calf. Roughly 40% of the reproductive events we've seen, at the first reproductive events, roughly 46 occur at 3 years old, 39 at 4 years old. And then down here, this shows that even our 5 and 6 year olds are having first reproductive events. It's hard for me to believe that that's actually true. Early on in the study, we were only flying parturition surveys kind of right at peak parturition. So you can think of the parturition window as a bell curve. In early May, it starts off slow. And then in our area, by about May 24 is when calves are hitting the ground at the fastest rate. And then it tapers off again into early June until every pregnant cow has had her calf. So early on, we were checking only that peak time. So especially then in those early years, we know we've missed some reproductive events. More recently, we've been doing 3 parturition checks throughout the parturition period. A early parturition check, mid parturition or peak parturition check, and a late parturition check. So more recently, we're getting better coverage of that parturition window. So hopefully we're not missing as many. It's hard to say that we're catching all of them. But yeah, this 5 and 6 year old age class first reproducing at these ages, I don't tend to believe that's true. But still, the fact that, moose are waiting until 3 or 4 years old to reproduce is another indication that, the habitat is stressed and they're not quite getting their nutritional needs met. So just to summarize, lower Yukon moose calves have lower mass going into winter and at the end of winter. Obviously, we have data to support that is winter habitat is likely a problem. But also the adults, they're obviously not getting, nutritionally what they need to allocate enough resources into their calves, which is also indicative that we might have some summer habitat limitations as well, because moose don't get fat in the winter. They gain fat in the summer. And if they are not, eating enough food to gain fat and also produce milk for their calves, indicates there may be a summer habitat limitation as well. Some moose make large summer movements up to hundreds of miles, but almost all of them return right to where we captured them for the winter. And 1/3 to 1/2 of moose do not survive their first year. Adults generally have good survival probability, but suffer other effects, delayed breeding, reduced parturition rate, and we weren't capturing them right when they hit the ground, but certainly in the fall time and in the springtime, they're having lighter calves. So what do we hope to do with this information? This study will help us determine, hopefully, how many moose the landscape can support, determine bag limits on moose. Right now, we have a 3 moose per year bag limit. If this population were to turn the corner and start declining, we don't want to keep that up and not know that population decline is occurring, because really we could kind of help drive this population down more than it really needs to be. So kind of give us a signal of when to back off on those liberal bag limits we have now. Hopefully predict when a moose population might decline. Refine field measurements to better understand the nutritional condition of moose populations, and understand how habitat responds to high moose density and release from high moose density. And here I've got another short video. I just wanted to show you what a lot of moose looks like on the landscape. So this is on the lower Yukon, maybe 30 miles downriver of Mountain Village in the lowest Yukon survey area. This is in 2021 when we did our moose survey. And just for a little background, when we do a moose survey, we go out and we count every moose in blocks that are roughly 6 square miles. So we've got, say, 280 of those blocks, and we'll go sample roughly a third of them and do some math to come up with our estimate. But in this block right here that we're going to show the sandbar, we counted, about 360 moose. And this is just one sandbar in that unit. If you want, you can try and count how many moose you see. I'll tell you how many I counted when I just kind of watched it and counted every moose I saw. And yeah, enjoy. There's part of the sandbar. It's a lot of moose, but it just keeps going and going. So when I watched that video, I didn't pause it and go frame by frame or anything like that, but I just counted as fast as I could, and I counted 91 moose. There is almost certainly more than that. I talked about those 6 square mile blocks. If in other parts of the state, if they found 91 moose in that 6 square mile block, they'd be absolutely ecstatic. And here on the lowest Yukon River, we have that sitting on some sandbars.